Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Today we're going to explore Google App Engine, or GAE as we'll often call it. This is one of Google Cloud's most powerful platform as a service offerings, and I'm excited to show you why it's been a game changer for so many developers. Let me start with a quick story. A few years ago, I was working with a startup that needed to deploy their application quickly. They had a small team, no dedicated DevOps engineers, and needed something that could scale automatically. Google App Engine was the perfect solution. Within hours, not days or weeks, they had their app running in production. What makes App Engine special is that it handles all the infrastructure complexity for you. You literally just write your code and deploy it. No servers to manage. No load balancers to configure, no OS patches to worry about. It's like having an entire operations team built into the platform. App Engine Architecture Overview. Now let's dive into how App Engine actually works under the hood. This diagram shows the key components of the App Engine architecture, and I want you to notice how everything is designed for automatic scaling and high availability. At the top, we have the Google front end, which is basically Google's global load balancer. This is the same infrastructure that powers Google Search and YouTube, so you know it's battle-tested. When a user makes a request, it automatically routes to the nearest edge location. The App Engine service is where your application actually runs. Notice how I've shown multiple instances. This is because App Engine automatically creates and destroys instances based on traffic. During Black Friday, you might have 100 instances running, but at 3 a.m. on a Tuesday, maybe just one or two. All the supporting services like Data Store, Memcache, and Task Queues are fully managed. This means you get enterprise-grade databases and caching without having to be a database administrator. It's all just there, ready to use. Standard versus flexible environments. One of the most important decisions you'll make with App Engine is choosing between the standard and flexible environments. Let me break this down because it's crucial to get this right. The standard environment is like living in a well-furnished apartment. Everything is provided for you: the runtime, the libraries, even the web server. It starts up in seconds, literally. I've seen apps go from zero to serving requests in under 2 seconds. The trade-off is that you're limited to specific language versions and can't install custom system packages. The flexible environment is more like having your own house. You can customize everything, install any software, use any language version, even SSH into the instances if needed. But with great power comes great responsibility. Instances take minutes to start up, and you pay for them even when idle. In my experience, about 80% of applications work perfectly in the standard environment. Start there unless you have specific requirements that demand flexible. Key features and benefits. Let me highlight the features that make App Engine truly special. These aren't just bullet points from marketing materials. These are the features that have saved me countless hours of work over the years. Automatic scaling is the killer feature. I once worked on an educational app that got featured in an app store. Traffic went from 100 users to 100,000 users in about an hour. With traditional hosting, the site would have crashed. With App Engine, it just worked. New instances spun up automatically, handled the traffic, then spun down when things calmed down. Version management and traffic splitting are incredibly powerful for deployments. You can deploy a new version, send 5% of traffic to it, monitor for errors, then gradually increase. If something goes wrong, one command rolls everything back. No more scary Friday deployments. The integrated monitoring and logging are enterprise grade. You get detailed metrics, error reporting, and trace analysis out of the box. What would normally require setting up Elk Stack or Datadog just works automatically. Supported languages and runtimes. App Engine supports a wide variety of programming languages, and the list keeps growing. Let me walk you through what's available and share some insights about each. Python was the first language supported, and it shows. The Python runtime is incredibly mature and well optimized. If you're building web apps with Django or Flask, this is a fantastic choice. The Python 3 runtime includes most popular libraries pre-installed. Java support includes not just Java, but any JVM language, Kotlin, Scala, Groovy. I've deployed Spring Boot applications that just worked out of the box. The Java runtime also supports WAR file deployments if you're migrating legacy applications. Node.js is perfect for modern JavaScript applications. Whether you're using Express, Fastify, or any other framework, it works great. The NPM ecosystem is fully supported. Go deserves a special mention. It's Google's own language, and the integration is seamless. Go apps start up incredibly fast and use minimal memory, making them very cost-effective on App Engine. App Engine deployment flow. Now let's look at how deployments actually work. This is where App Engine really shines compared to traditional hosting or even other cloud platforms. The deployment process starts with your code and an app YAML file. This YAML file is like a recipe that tells App Engine how to run your application. You specify the runtime, any environment variables, and scaling settings. When you run gcloud app deploy, several things happen behind the scenes. First, your code is packaged and uploaded to Google Cloud Storage. Then, App Engine builds a container image. Yes, even standard environment uses containers under the hood now. This image is optimized for fast startup and minimal resource usage. The beautiful part is the traffic migration. New instances are started with your new code. Health checks ensure they're working properly. Then traffic is gradually shifted over. Your users experience zero downtime. If health checks fail, the deployment automatically stops and rolls back. Version management means every deployment creates a new version. You can have multiple versions running simultaneously and split traffic between them. This is incredibly powerful for A/B testing or gradual rollouts. Essential gcloud commands. Let me share the gcloud commands you'll use every day with App Engine. I'll explain not just what they do, but when and why you'd use them. First, gcloud app deploy is your bread and butter. But did you know you can add flags to make it even more powerful? The version flag lets you specify a custom version name instead of using timestamps. I like to use git commit hashes for easy tracking. The no promote flag is a lifesaver for testing. It deploys your new version but doesn't send any traffic to it. You can then use the version-specific URL to test everything before promoting. gcloud app browse. Seems simple, but it's surprisingly useful. After deployment, it opens your app in the browser. Add version to open a specific version. gcloud app logs tail gives you real-time logs. During debugging, I often have this running in a terminal window. The S flag lets you filter by service, which is crucial in microservice architectures. Version management commands are critical for production apps. You can list all versions, see which ones are serving traffic, and clean up old versions to save costs. Configuration with app YAML. The app YAML file is the heart of your App Engine configuration. Let me show you a real-world example and explain each section. The runtime specification tells App Engine which language environment to use. Always use the latest stable version unless you have compatibility issues. For Python, Python 39 feet or Python 310 feet are current standards. Environment variables are crucial for configuration. Never hardcode API keys or database passwords in your code. Use env variables in app YAML for non-sensitive config, and Google Secret Manager for sensitive data. Scaling configuration is where you can really optimize costs. For development, manual scaling with one instance saves money. For production, automatic scaling with min_instances ensures fast response times while max_instances prevents bill shock. Handlers are powerful but often misunderstood. You can serve static files directly without hitting your application code, which is much more efficient. The secure. Always setting forces HTTPS, which you should always use. Instance class affects both performance and cost. F1 is fine for simple apps, but CPU-intensive apps might need F2 or F4. In flexible environment, you can specify exact CPU and memory requirements. Deploying a Python Flask application. Let's walk through deploying a real Python Flask application. This is one of the most common use cases, and I'll show you exactly how to do it step by step. First, notice the project structure. Keep it simple. app.py for your main application, requirements.txt for dependencies, and app YAML for configuration. The gcloud ignore file is like gitignore but for deployments. Use it to exclude test files, documentation, and local virtual environments. The Flask app itself is standard Python code. The key thing is that App Engine expects your app to listen on the port environment variable. Always use OS environ.get port 8080 to ensure compatibility. The deployment commands I'm showing include some pro tips. Using project explicitly avoids deploying to the wrong project. Trust me, it happens. The version flag with a timestamp helps track deployments. And no promote lets you test before going live. After deployment, always check the logs. Even if the deployment succeeds, your app might have startup errors. The logs tail command with grep helps filter out the noise and focus on actual errors. Testing the deployed version before promoting is crucial. Use the version-specific URL to run through your test cases. Only promote to production after verification. Deploying a Node.js application. Now let's deploy a Node.js application. The process is similar to Python, but there are some Node-specific considerations I want to highlight. The package.json file is crucial. App Engine uses the start script to run your application, so make sure it's defined correctly. Also, specify the Node version in the Engines section to ensure consistency between development and production. For the Express app, notice how we're handling both production and development environments. In production, App Engine sets node_env to production automatically. Use this to enable optimizations like view caching and minification. One Node.js specific tip. Be careful with native modules. Some NPM packages include C++ extensions that might not work in App Engine standard. If you encounter issues, try the flexible environment or look for pure JavaScript alternatives. The deployment process is identical to Python, which shows the beauty of App Engine's consistency across languages. The same gcloud commands work regardless of your runtime. For Node.js apps, pay special attention to cold starts. Use lightweight frameworks and lazy load-heavy dependencies to minimize startup time. Every millisecond counts when App Engine is spinning up new instances. Automatic scaling configuration. Automatic scaling is where App Engine really earns its keep. Let me explain these settings because getting them right can save you thousands of dollars while ensuring great performance. Target CPU utilization is the primary scaling metric. At 0.6, 60%, App Engine starts spinning up new instances. This leaves headroom for traffic spikes. I've found 0.6 works well for most web apps, but CPU-intensive apps might need 0.5 or lower. Min instances is your baseline. Setting this to 1 or 2 eliminates cold starts for your typical traffic. Yes, you pay for idle instances, but the improved user experience is usually worth it. For production apps, I rarely go below 2 for redundancy. Max instances is your safety net. Without this, a DDoS attack or viral traffic spike could result in a huge bill. Calculate based on your maximum acceptable cost. Remember, each instance can handle many concurrent requests. Target throughput utilization works alongside CPU utilization. If your app handles 50 requests per second per instance, and you set this to 0.8, App Engine adds instances when you exceed 40 requests per second. This is crucial for I/O-heavy applications. The diagram shows how these settings work together. As traffic increases, App Engine monitors both CPU and throughput, scaling up when either threshold is exceeded. The beauty is that it scales down just as automatically when traffic decreases. Traffic splitting strategies. Traffic splitting is one of App Engine's most powerful features for safe deployments. Let me show you how to use it effectively for different scenarios. The basic concept is simple. You can run multiple versions of your app simultaneously and control what percentage of traffic goes to each. But the strategies for using this are what make it powerful. For canary deployments, start with just 5% of traffic to your new version. Monitor error rates and performance metrics. If everything looks good after an hour, increase to 25%, then 50%, then 100%. If anything goes wrong, you can instantly route all traffic back to the stable version. A/B testing is another great use case. Deploy two versions with different features or UI changes. Send 50% of traffic to each and measure conversion rates or user engagement. App Engine ensures the same user always sees the same version, maintaining consistency. The gcloud commands for traffic splitting are straightforward. The splits flag takes a comma-separated list of version equals percentage pairs. Always make sure your percentages add up to 100, or the command will fail. IP-based splitting ensures users get a consistent experience. Cookie-based splitting is more precise but requires cookie support. Random splitting is great for true A/B tests where you need statistically valid samples. Monitoring and logging. Good monitoring and logging practices are essential for running production applications. App Engine provides powerful tools, but you need to know how to use them effectively. Cloud logging captures everything: application logs, request logs, and system events. The key is learning to filter effectively. Use severity levels in your application, info, warning, error, to make important events stand out. Don't log sensitive data like passwords or personal information. Cloud monitoring gives you metrics about instance count, latency, error rates, and more. Set up alerts for anomalies. For example, alert if error rate exceeds 1% or if P95 latency exceeds 500 milliseconds. These early warnings help you fix issues before users complain. Error reporting is a hidden gem. It automatically groups similar errors, shows stack traces, and tracks error frequency over time. When you deploy a new version, check error reporting first. New errors often indicate deployment issues. CloudTrace helps diagnose performance problems. It shows exactly how long each part of a request takes. I once found a database query taking 3 seconds that should have taken 30 milliseconds. Without Trace, it would have been nearly impossible to identify. The gcloud commands I'm showing are for quick debugging. But for serious monitoring, set up dashboards in the Cloud Console. Create custom metrics for business-specific events like user signups or purchases. Cost optimization strategies. Let's talk about money, specifically, how to avoid wasting it. App Engine can be very cost-effective, but you need to understand the pricing model and optimization techniques. First, understand what you're paying for. In standard environment, you pay for instance hours, not clock hours. If an instance serves requests for 5 minutes then shuts down, you pay for just those 5 minutes. This is why standard is often cheaper than flexible for variable traffic. Instance class selection matters. An F1 instance costs half as much as an F2 but has half the CPU and memory. For many apps, 2 F1 instances handle load better than 1 F2 and cost the same. Test different configurations. Idle instances are a major cost. Set max_idle_ instances appropriately. During low traffic, you don't need multiple instances sitting idle. Use the warm-up request feature to make new instances ready faster instead of keeping idle ones. Clean up old versions. Each deployed version consumes some resources even if it's not serving traffic. I've seen projects with hundreds of old versions costing hundreds of dollars monthly. Set up a cleanup script that keeps only the last 10 versions. The table shows real cost comparisons. Notice how different configurations can have dramatically different costs for the same traffic. The key is finding the sweet spot between performance and cost for your specific application. Security best practices. Security is non-negotiable for production applications. App Engine provides excellent security features, but you need to configure and use them properly. Always use HTTPS. The secure always handler setting enforces this. App Engine provides free SSL certificates, so there's no excuse for using HTTP. Even for APIs, always use HTTPS to prevent man-in-the-middle attacks. Identity and access management. IAM controls who can deploy and manage your app. Follow the principle of least privilege. Developers might need App Engine deployer role, but not App Engine admin. Use service accounts for automated deployments. For secrets management, never put sensitive data in app, YAML or your code. Use Google Secret Manager for API keys, database passwords, and other secrets. App Engine can automatically inject these as environment variables at runtime. Enable Cloud Armor for DDoS protection if you're expecting high traffic or have security concerns. It can block malicious IPs and rate limit requests. For APIs, implement your own rate limiting to prevent abuse. The App Engine firewall lets you control access by IP range. This is perfect for admin interfaces or internal APIs. You can whitelist your Office IP or VPN ranges while blocking everything else. Regular security scanning is crucial. Use Cloud Security Scanner to find vulnerabilities. It tests for common issues like XSS, SQL injection, and outdated libraries. Troubleshooting common issues. Let me share solutions to the most common App Engine problems I've encountered. These will save you hours of debugging. 502 errors usually mean your app is taking too long to respond. App Engine has a 60-second timeout for requests. If you have long-running operations, use task queues or cloud functions instead. Also check for memory issues. If your app runs out of memory, it gets killed and returns 502. Deployment failures often come from app YAML syntax errors or missing dependencies. Always validate your YAML locally. For dependencies, make sure requirements.txt or package JSON includes everything. Test deployment in a staging project first. Memory errors are tricky because they don't always show clear error messages. If your app randomly restarts, check memory usage. Use cloud monitoring to see memory metrics. Consider upgrading instance class or optimizing your code. Cold start issues affect user experience. Minimize dependencies, lazy load modules, and consider keeping minimum instances running. For Java apps, avoid heavy frameworks like Spring if cold starts are critical. The table I'm showing lists specific error codes and their solutions. Bookmark this. You'll reference it often. Remember, most App Engine issues have been encountered before, so check Stack Overflow and Google Cloud documentation. Integration with other GCP services. App Engine really shines when integrated with other Google Cloud services. Let me show you the most powerful combinations I've used in production. Cloud SQL is the natural database choice for App Engine. Use the Cloud SQL proxy for secure connections. Pro tip: in-app YAML, use the Unix socket connection instead of IP for better performance and security. Always enable automated backups. Firestore is perfect for NoSQL needs. It scales automatically and integrates seamlessly with App Engine. Use it for user sessions, real-time features, or any document-based data. The client libraries handle authentication automatically. Cloud storage is essential for file uploads and static assets. Never store uploaded files on App Engine instances. They're ephemeral. Use signed URLs for secure uploads directly from browsers to cloud storage, bypassing your app entirely. Cloud Tasks is a game changer for background processing. Instead of making users wait for email sending or report generation, queue a task and return immediately. Tasks retry automatically on failure, ensuring reliability. Pub/Sub enables event-driven architectures. When a user uploads a photo, publish an event. Separate services can then generate thumbnails, scan for inappropriate content, and update search indexes, all asynchronously. The architecture diagram shows how these services work together. Notice how App Engine sits at the center, orchestrating everything while letting specialized services handle specific tasks. Real-world case studies. Let me share some real-world examples of App Engine in production. These case studies show both the power and the practical considerations of the platform. The e-commerce platform example is particularly interesting. They migrated from AWS EC2 where they managed their own servers. The migration reduced their operational overhead by 70% and improved Black Friday performance. App Engine automatically scaled from 10 to 200 instances during peak traffic. The mobile game backend showcases App Engine's ability to handle spiky traffic. When players finish work or school, traffic increases 10x within minutes. Traditional infrastructure would require over-provisioning, but App Engine scales just in time. The SaaS application demonstrates multi-tenancy on App Engine. Each customer gets their own subdomain, routed to the same App Engine service. They use Firestore for data isolation and cloud tasks for per-tenant background jobs. The media streaming service is a great example of App Engine with CDN integration. App Engine handles API requests and authentication, while Cloud CDN serves actual video content. This separation of concerns optimizes both performance and cost. Key lesson from all these cases: App Engine works best when you embrace its patterns. Don't try to force traditional architectures. Design for stateless, horizontal scaling from the start. Summary and best practices. As we wrap up, let me summarize the key takeaways and best practices for succeeding with Google App Engine. First, choose the right environment. Start with standard unless you absolutely need flexible. The faster scaling, lower costs, and simpler management of standard environment make it the better choice for most applications. Design for scalability from day one. Keep your application stateless, use managed services for data persistence, and handle async operations with cloud tasks or pub/sub. These patterns ensure your app can scale from 1 to 1 million users. Monitor everything. Set up alerts, check logs regularly, and use error reporting to catch issues early. The best time to fix a problem is before users notice it. Create dashboards for business metrics, not just technical ones. Practice continuous deployment. Use Cloud Build for automated testing and deployment. Deploy frequently in small increments rather than big, risky releases. Traffic splitting makes this safe and easy. Keep learning. Google regularly adds new features to App Engine. Join the Google Cloud community, attend webinars, and experiment with new capabilities. The platform keeps getting better. Remember, App Engine's goal is to let you focus on your application logic, not infrastructure. Embrace this philosophy and you'll build more reliable, scalable applications with less effort. Thank you and resources. Thank you for joining me on this deep dive into Google App Engine. I hope you've gained practical knowledge that you can apply immediately to your projects. I've included links to essential resources that will help you continue your App Engine journey. The official documentation is comprehensive and well maintained. The quick start guides are perfect for getting hands-on experience with different languages. The community resources are invaluable. Stack Overflow has thousands of answered App Engine questions. The Google Cloud community forums have Google engineers who actively help with complex issues. The subreddit is great for discussions and seeing what others are building. For further learning, I highly recommend the Google Cloud Skills Boost platform. They have hands-on labs where you can practice App Engine deployments without using your own credit card. The Coursera specialization goes deep into cloud architecture patterns. Remember, the best way to learn App Engine is by building something. Start with a simple project, deploy it, and iterate. Each deployment teaches you something new. Feel free to reach out if you have questions. Good luck with your App Engine projects, and happy coding. Thank you for your attendance. Please consider subscribing to the channel.